Not all the energy we start with is transferred into exactly what we want it to be transferred into. Now, some of the energy is wasted along the way. And then over here, we see this illustration. Now, not all the energy we start with is transferred. Some of the energy is wasted in producing other forms of energy. Now, if I want to run, some of the energy stored in me will be used for the motion, for the running. Other forms of the energy, or some of the energy, will also be used in producing sound energy. Some of the energy will be used in producing heat energy. So although my primary intention is to use the energy stored in me to run, the energy, some of the parts of the energy is going to be used for the production of heat. Another part of the energy will be used in production of sound as I hit my feet against the ground. Over here, we put 100% fuel into this machine. Along the way, 2% will be used or will be lost in blowdown losses. A further 2% will be lost in leakages. So as we put the fuel in there, not all the fuel is being used. Along the way, 3% will be lost in standing losses. Pipe work installations will also take 5% away. Condensate losses will take 5%. 10% steam trap losses. Over here, the 10% is very huge. And then a further 18% in stack losses. So all these are showing that although we put 100% in there, only 55% will be used in the production of heat. Only 55% useful heat output out of the 100%. So 45% will be lost down here. This takes us to efficiency. A person or device will do work with the energy supplied to it. And as I said, not all the energy supplied will be transformed. The amount of useful work done with the total energy supplied is what we call efficiency. So how efficient a person is will depend on how much the person is given and then how well he or she does. Efficiency is equal to useful energy output over energy input. Useful energy output over energy input. This will give us an answer in a fraction or a decimal. If we want our answer in a percentage or a percent, we just multiply this by 100%. So after dividing, whatever we get, we multiply by 100% to give us our answer in the percent. So efficiency is equal to useful energy output. How much energy you're going to, how much results you're going to produce with the resources you've been given. That will tell us how efficient you are. Another one is efficiency is equal to useful power output divided by the power input. So if you're giving your car more fuel and then the car is doing less work, that means clearly the engine has a problem. If you want this one in percentage, we multiply by 100%. So efficiency is just dividing the output by the input, and then you multiply by 100% if you need your answer in the percent form.